However, we need to know how to simplify factorials, especially similar or numbers that are close together. I want to talk about what is 5 factorial first. I explain from there. 5 factorial means you are going to multiply all the way to the value 1. This can be broken down into 5 times 4 factorial, because 4 times 3 times 2 times 1 is 4 factorial. And we can always further break it down to smaller numbers if you want. It's the same as 5 times 4, then 3 factorial. So how is that useful? Let's say you want to simplify a fraction that is almost the same number, differing just by 1 or 2 in the factorial. Always open up the bigger of the two. 5 is bigger than 4. So open up the 5 as 5 times 4 factorial, so that it can help you create the cancellation of 4 factorial and 4 factorial. So I get 5. Always open up the bigger of the two. Second one, similar. This will be seen as 6, 5, 4 factorial. Open up that 6 factorial. So I get 1 over 30 in the cancellation. But this technique is mostly to deal with if there is an unknown like here. I open up the top because the top is larger, and keep simplifying until you get the smaller factorial below to appear. So 10, 9, 8, and we divide by 8. Okay, let's apply it to this question here. So Roy has 5 triangle r plus 1 squares. We are going to select 5 blocks without replacement. They tell me that the probability of Joy having exactly 2 squares is twice the probability of exactly 4 squares. Let's solve for r. We start from that question, that last statement. We form the equation first. They are telling me probability exactly 2 squares is twice probability exactly 4 squares. Okay, let's do something similar to that ball problem. If I need 2 squares from r plus 1 squares, we choose from the r plus 1. But I need to form up 5 blocks. They have 5 blocks. So from the triangle, I need to choose another 3. From triangle 5, we choose 3 to form up 5 blocks. This is a probability. There needs to be a denominator. Denominator will be choosing 5 blocks without restrictions. Without restrictions. So can be from triangle or square. In total, you have r plus 6 blocks. We choose 5. Denominator is the no restrictions for 5 objects. Right-hand side, similar. Exactly 4 squares, so r plus 1, choose 4. 5 triangle, choose 1. There are similar terms appearing to the left and right. We can get them cancelled. So these two cancels out. Those with unknown of r, you continue to write out first. But if there is no unknown, such as A5, choose 3, you could immediately press your calculator to get the value. This is 10. So right-hand side, similar, it happens that 2 times 5, choose 1 is also a 10. 2 times 5, choose 1 is also 10. Again, these two 10s cancel out. There will be 2 methods to proceed from here. and I write both. Method 2 will be GC. We do that later. Let's do without GC first, in case the question restricts the use of graphing calculator. In order to open up those unknowns with R, you apply the n choose R formula above. So that means this left side is R plus 1 factorial. Bottom left, 2 factorial. Bottom right, you subtract the two values. R plus 1 minus 2, I immediately write as minus 1. Right hand side, let's do the same. And R minus 3 factorial. Again, we should observe certain cancellations. Those that are left over, could we try to group up similar terms into a fraction? For example, this 4 factorial, I want to move to the left to combine with the 2 factorial. Those with R, we move to the right. Group up the similar factorial terms together. 4, I move left. R minus 1, I move right. So the above explanations was to prepare for this step. We open up the factorial, open up the bigger of the two. So your similar terms will be directly cancelled. The yellow terms are cancelling each other out, top and bottom. So when we solve, we will get R is 5 or minus 2, but this is rejected because the question on the first line mentioned R is at least 3. You need to understand this manual method without the graphing calculator in case they restrict the use of GC. Okay, so method 2 GC is the faster of the two methods. Just right here, I'm trying to solve for these two to be equal. It's actually one of the methods from J1 that we should already know. The crucial information is R is an integer. You will have a lot of this in statistics later on. How I know R is an integer? It's because R plus 1 blocks. It's assumed that R is a whole number, cannot be decimals, for example. If you have integer, graphing calculator, the best way is to solve with a table. But to do a table, I will recommend we always move everything to one side, force it to be a 0. So you want to press onto your GCS, you key like a Y equation. Your R is your unknown. We key this way. And go for a table. So I have keyed that equation here. If I key this into the graph, by the way, where do you get your n choose R on the GC? You go for math, and it's under probability. There will be n choose R number 3. Okay, math prob will have n choose R. So go for table. Table means you press second graph. When I press second graph, we will see that there must be that one value that will give me 0. I'm aiming for 0. So this is 0 occurs when your x is 5. You don't need to draw the table for them. There's just that one value. You can just say using GC. Then I get R is 5 straight away. In fact, you are going from this line directly to this line. All those in the middle is I'm trying to show you what I did. So when can we use a table method from now on? Anytime your R is whole number, don't bother to solve. No need to simplify anything. Just go straight to table, unless they restrict GC in that question.